So in this video, we're going to be finding maximums and minimums of applications, and this one is a business, and in following ones, we'll do some more different types, some fun stuff. But we have our basic rules, so just to go over it, our first derivative is positive for x less than c. So what that means is if we look at it, we have some c value here of 0. So if we're less than c, all our x values, what we have is a positive slope. So it looks like this. And then for all values greater than c, we have a negative slope. So it looks like this. So when we have that situation happening, where it's positive to the left and negative to the right, then what we know we have is a maximum. And if our first derivative is negative and then positive, then that means we have an absolute min. So all these definitions are just telling us is that if we are always increasing like this, and then always decreasing after that maximum value, then we know that that is our maximum value. So if we take the derivative, set it equal to 0 for these functions like polynomials, then that's going to give us our maximum or minimum. So if it's decreasing and then increasing, it's our min, but all we have to do is take the derivative, set it equal to 0, and that's going to give us our relative extreme, our actual extrema, max and min. So let's try a problem. So we have our price function, our revenue function, and our cost function. And P is in the price. Q is in thousands of units. That's our quantity sold or produced. R is the revenue in thousands of dollars. And C is the total cost in thousands of dollars. So everything's in thousands except for the price. Okay, so find the production level Q that will minimize cost. So when you're talking about these problems, you always want to look and see what is the thing that's being minimized or maximized. That's the function we're looking at because we want to see what our graph is. So our cost function here is a parabola. So we know it looks like this. And so you can see that there is some value right there that is our critical number that will give us our minimum. So if it says minimize or maximize, the word right after it is the function you want to use. So we need to take and find the derivative of the cost. So 2q minus 5, we set it equal to 0. Q equals 5 halves, which is 2.5. And then we change it into what it is. So it's in thousands of units. So if you multiply that by 1,000, we get 2,500 units. So what is the production level that will minimize cost? 2,500 units. And you can plug this in your calculator and verify it. So again, we don't plug in the derivative. That's just going to tell us our rate of change. We always plug in the function that we're using. So I've done that. And then we need a good window. So we've already found that it should be at 2.5. So if I go from 0 to 5, hit zoom 0, you can see it's right at 2.5. So if I hit trace 2.5, you'll see our minimum. So that means 2,500 units, and this is our cost. So we have a minimum cost of $68.75. Didn't ask for it, but there it is, $68.75. So that would be $68,750 for our minimum cost. All right, let's try maximum revenue. So if we're going to maximize, come on, blue, revenue, then we're going to use the revenue function. So let's take the derivative. C prime, revenue. R prime of Q equals 37 minus 4Q. Set it equal to 0. That means our Q is 37 over 4, or 9.25. And again, Q is in units of 1,000. So that means 9,250 units. However, it didn't ask for the number of units. It says find the maximum revenue. So once you plug these units back in, it will tell us the revenue. So to do that, I would always graph it and take a look at that calculator's picture. So we plug in our revenue. We hit window and 9.25. So again, we want to place it in the middle. So we'll go to like 18.5. Hit zoom fit. And there we have it. So trace 9.25. So that means our quantity of 9.25, 9,250. And there's our revenue. So 171,125. So R of 9.25 equals 171.125 I already said it wrong. 125, good. And again, this is in thousands of dollars. So multiply it by 1,000, and we get 171, comma 125 dollars. So what is the maximum revenue? 171,125. You can see that our revenue is increasing, and then after that it is decreasing. So if they sell more than 9,250 units, they lose money. That's what's happening. So there's the optimum number of units for revenue. So let's look at the next one now. Now it says find the maximum profit. So what function do we use? You guessed it, profit. The key is to focus on what we are maximizing or minimizing. So if we take the revenue and the cost and subtract them, so we're going to take our revenue function, which is 37q minus 2q squared, and subtract the cost function, so q squared minus 5q plus 75, which gives us negative 3q squared. All I'm doing is changing all of these signs. So this would now become positive 5q, so plus 42q, and then minus 75. So we get negative 2q, that's minus 3 plus 42 minus 75. And then to maximize this, we take, you guessed it, the derivative. So negative 6q plus 42, set it equal to 0. This means that q is equal to 7. And so that would become 7,000 units. And now we need the maximum profit. So we're going to plug this in. I always say plug in the original, and that way if you made a mistake simplifying, nothing will work out for you. So I plugged in the original function. So this is our profit function. That's revenue minus cost. So then I know it's going to go from 0 to 14 because we have 7 for our q. Graphing it gives us this, and everything looks good. So if I hit trace and 7, you can see that is perfectly our max profit, which is 72. So that means our max profit is $72,000. So if they sell 7,000 units, it will maximize the profit of 72,000. And then we can also do the price that maximize. See, the whole point is, what did we take the derivative of? The profit. That gave us a Q value. That Q value can be used to find the price, the revenue, and the cost. So we could even see what revenue maximizes profit. It's weird, but it's a possible question. But what we want to know is what price. So what price do they sell it for to maximize profit? So if we take that 37 minus 2, plug our 7 in, we get $23. So for what price? $23. So if they sell it for $23, they will sell 7,000 units and maximize profit of 72,000. Again, these are just predictions. These formulas are all based on data that they've collected, but they now have at least an idea of where they should be pricing their unit. All right, and then you can even keep going. Say find the production level Q that will minimize the average cost. So now we find the average cost. Average cost is cost divided by X, like we did in a previous problem. So if we take our Q squared minus 5Q plus 75, and in this case it's divided by Q, because that's our quantity, we would get Q minus 5 plus 75 over Q. And then if we want to minimize that average cost, we take the derivative. So let's rewrite this. So we're going to take the derivative because we're minimizing the average cost. So this would be 1 minus 0 minus 75, so negative 1. So it'd be, minus 75 q to the negative 2. So this is 1 minus 75 over q squared. And then again, we have to write this as a fraction to find our critical numbers. So multiplying top and bottom by q squared, we end up with this. So again, this is q squared over q squared. And then now you can set the top equal to 0 and the bottom equal to 0, but we can't have q equal to 0 from the beginning. So just the top. So q squared equals 75, square root, and we get q equals plus or minus 75. But again, we're talking about quantities that are positive, so it's just a square root of 75. which would be 5 rad 3, and that's approximately 8.66. So we end up with 8,660 units to minimize the average cost. And we can check this in our calculator. So I've plugged in the average costs, and then I want to look around that numbers. So I have 7 and 10, because that's 8.66. So if I hit zoom 0, we end up with that. And so now trace, and then it's a square root of 75. You can put it in a unsimplified form. Hit enter. We get this. So you can see right there, it's not even on the screen. It's not blinking. That's perfect. That means that's our minimum. And so it's 12.32. So 12,000, right? Our average cost would be $12.32. So there you have it. So whatever you're trying to minimize or maximize, that is what you want to take the derivative of, set equal to 0, and it'll give you the x or q or whatever letter it gives you, and then you can plug it in to answer any question that they want. Thank you.